Alright. So in this lesson we're going to be learning how to change repeating decimals into fraction. Because you guys should be able to do terminating decimals already. Or not. Either way we're going to do both. But we're focusing specifically on the repeating decimals. That is our objective for today. Eat it! Alright. As we discovered in the previous section, when we converted fractions into decimals, the result was either a terminating or repeating decimal. That's because they were rational. If we are given a terminating or repeating decimal, we need a method for changing them into a fraction in order to prove that they fit the definition of a rational number. In 7th grade, you learned how to convert terminating decimals into fractions. Here are some examples. Those three specifically, we did last time. Last time we did these three as the bell work, where you guys change these decimals into fraction. Alright, so this last one, Radical, this is a mixed number because it has a 1 value, the -2. So we make it -2, that 6 is in the hundredths position, so we make it -2 and 6 100ths, Radical. Well, if we simplify 6 hundredths, we would get 3 50ths. And then to change this into an improper fraction, which are much better than these mixed number stuff, we would do 2 times 50, which is 100, plus 3. 103 50ths, we keep the negative, bam. Alright, let's do this one. Alright, this is 4. And for the denominator in the fraction, again, we're looking at the place value of the 4, which is, in this case specifically, the tenths value. And we can't simplify both of these because they're even, at least by dividing both of them by 2. That would give us 4 divided by 2, which is 2, and 10 divided by 2 is 5. Now we cannot simplify this any further, and we are done. Alright, good luck.
Okay, so because this is this is the hundredths place right there, so it'd be 5 over 100, and 5 can go into 100, so that'd be 1, and then 5 can go into 100 20 times.
Bam. That is excellent. Good luck.
Yo, what's up, guys? Your boy Matthew here. So we're gonna put this into a fraction, which is 200. Wait, oops. Sorry, guys. 275 over 1,000. Okay, so if we divide both sides by 25, that will give us a total of 11 over 40. And that's quick maths for you. Hand it off to Mr. Sell.
Wait, that is good. That was excellent. So that you don't have to... Good luck.
Alright. So we have 1 and 3 1,000ths. So if we just write this out here. And then, but that is not an improper fraction, so we need to change it into 1. So 1 times 1,000 would be 1,000 plus 3. So it'd be 1,003 over 1,000. And you can't simplify that.
That is correct. Excellent work. So how do we express a repeating decimal as a fraction? For example, how would you convert the repeating decimal of 0.45 repeating into a fraction? Try in the space below. Alright, so we see a lot of this on you guys' worksheets, right? 45 over 100, which actually is a pretty good guess on that stuff, okay? Because what would this give you? It would give you 0.45. It just wouldn't repeat, right? So it's pretty close. The problem is we do need to show that it does repeat. We can use a system of two linear equations to convert a repeating decimal into a fraction. Let's look at an example. You guys really like that system of equation stuff, so that's good. Example 1. The decimal 0.3 is a very common repeating decimal. That can be thought of as 0.3. It just goes on forever. Lots of 3s. Where we got those 3 dots that indicates that the 3s go on forever. If they repeat forever, how can we write this number as a fraction? Here is a trick that will eliminate our repeating 3's. So we're going to let a represent our number. A equals 0.3 repeating. We're going to multiply both sides of the equation by 10, which gives us a different equation. So here's what this means. So we started with a equals 0.333, and it repeats. But you see, if we multiply this by 10 and we multiply this by 10, then we get 10a equals 3.33, and the 3's repeat forever. See, and that's what they're talking about. That's two equations, the one in black and then the one in red. Well, if we expand these out a little bit, hopefully we'll see what kind of happens up in here. Alright, so there we go. We've expanded this. Instead of showing the bar notation, we're using the 3 dots to indicate that it goes on forever. Alright, I'm going to line these up a little bit differently though. So I'm going to take the black equation and move it to the bottom there. Alright, now with the systems of equations, not that we remember that stuff, but that's a 1a right there. And if I decide to myself, and I decide to subtract these, then I will have a new single equation. 10a minus 1a is 9a's. That's a 9.
How do you know that?
And then if we subtracted these, starting from the right, the 3's cancels, and these 3's cancels, and these 3's cancels, all the 3's cancels. So we end up with a 0 repeating right there. And 3 minus 0 is 3. So let me show this equation down the count. I got 9a equals 3. And if I wanted to solve for a, which is, remember that was 0.3 repeating, then I would divide both sides by 9er, giving me the 1a, and 3/9 can simplify into 1/3. So we can see up here that we had a equals 0.3 repeating, but also the fraction. So we can write it like these. Alright, before I show you guys the next method, let's try this one using the same method we just used. The decimal 0.54 bar notation is a repeating decimal again. So let's do this one. Here we go. So if I multiply this equation by 10, and I multiply this one by 10, I can move the decimal, but actually what I'm going to do on this one is I'm going to multiply it by 100. Here's why, is because I have two decimal places that are repeating, 2.
Wow.
So by multiplying it by 100, it's going to move the decimal twice. So now I've got 100 A's, which equal 54.54 and so forth. Now again, we're showing it like this so that when we do the subtraction, it will get rid of all of the decimals. A, on the other hand, was equal to 0, and I am lining the place values up on purpose here. Alright, so if I had only multiplied it by 10, then the 5's and the 4's wouldn't be lined up, so I can cancel out all the decimal places. But now, what I can do is I am ready to subtract these two. So I've got 100A minus 1A, which would be 99 A's. And this would equal, the 4's cancel, the 5's and 4's and 5's and 4's all cancel. And I've got 54 minus 0, which is 54. Now to solve these, I would divide both sides by 99er, which would leave me with just the A value. And 54/99, that appears, we should be able to simplify these by 9. So that would give me 6/11. Bam. So just so you guys could see that this is the case, go ahead and grab your calculator, do 6 divided by 11, see what you get. I subtracted the equation here in black from the one in red so that I could get rid of all these decimal places right here. See, that leaves me with this whole value, 54, and this whole value, which allows me to change it into a proper fraction. Why do you think we multiplied by 100 instead of 10? We talked about that. That was so that the place values would line up so that we could eliminate the decimal. Bam, there we go. Example 3, change the decimal 2.4 repeating into a fraction. The decimal 2.4 repeating is a repeating decimal that can be thought of as 2.4 repeating.
Could I please do it?
Again, it's just showing that it repeats in a different way instead of using bar notation. Thank you. Good luck.
So. Okay, so you start out with multiplying this by 10, so you get 24.444 forever. And then that equals 10a, then a equals 0.244 forever. And these cancel. Am I doing it wrong? Oh. So then you subtract these, I guess. So you get 9a and equals 22. And you divide that by 9, and you get a equals. Yeah, sorry.
You're fine. Keep going.
Divided by 9 equals. Well,
Just write the fraction. That's
yeah.
what we want.
Equals 22 over 9.
Bam. That is all. Excellent. Change this decimal into a fraction. Good luck.
Okay, so first we have to times 3.122 continuing by 100, and then that means it gets to 312.222, and then we have to, oh, that's what 100a equals. And then we have to minus 1a, which equals 3.122. And then that equals 99a. A equals 309.1, and then we have to change that out of a decimal. Wait, nope. First we divide it by, oh man, there's not enough room.
Oh, man. Continue.
Okay, and now we have to divide both sides by 99. And 99, which was 3, which equals A equals 3, wait, 0.12 continuing. Gosh dang it.
So if we go back to this thing, because we don't want to just say the value we started with, because we want to change it into a fraction. So you do have the 1a right there, and it equals that 309.1 over 99. But we don't want decimals and fractions, because it's very, well, people hate it. So we're going to multiply both of these by 10. And that would move the decimal over 1, but it's going to move the decimal over 1 here as well. So you end up with 3091 over 990. And as far as I can tell, these cannot be simplified.
They cannot.
So that is it. So yeah, we can simplify this. These are both divisible by 11. So yeah, that would give us 90 right here. And 281?
Yep.
Good. That was good. I'm glad you found that. So yeah, on most of your calculators, you can push second PRB, enter, and it will simplify the fraction for you.
Press what?
Even if it puts it into a mixed number, it will at least simplify the denominator, and then you got to change the mixed number back into an improper fraction. Second PRB, enter. That's with the TI-30s that we have here in class. If you have a non-TI-30, then it's usually second, and then at the very bottom left, there's an arrow. You push that button and it should work. All right, example 5. I'm going to show you guys a different way to do it, and I'm going to wait till later, actually. We'll use the same method on example 6. So yeah, let's go to example 7, because we should be using that same method on this. You can use the next method I'm going to show you on this, but it's a little bit more difficult. So if you can get this method down, you can use it any time, whereas the next method has to be. Here's the problem with the next method is, see that we got the 0 right there? It's going to throw us off if we use that method, okay? So be careful with that stuff. If we can just use this method, then we'll be good. Alright, so this is 2.015. Some of you guys like to multiply that stuff by x, so that's what I'm going to do. I'm going to say x equals this stuff. Well, to get the decimal past the 5, I'm going to have to multiply that by 1,000, right? So then I got 1,000.
But like the numbers don't line up, if that makes sense.
Yeah. If we multiply it by 1,000, the numbers are not going to line up. 2015.15, so forth. See, if we line this up, I need more space. Write this down here as 1x, then I got 2.015. So the place values are not matching up, so if we subtract this, we'll still have a repeating decimal. That's no good. So what that means is, yeah, I just need to tack on another 0 right there. That's going to move the decimal place over. See, so the decimal was right here. I'm going to move it right there by multiplying it by 10,000 now. So now I have that stuff. So with that, now I'm going to realign the x, which was, well, that's not right there. 2.015, and it keeps going. Now they're lined up so that when we do subtract, then we get 9,999 x's equals, doing the subtraction on this one, the 5's cancels, the 1, the 5's. We still have this decimal, and that's okay. We'll just move it later. I have to borrow 1 from that. 920,149.5. Well, I can move the decimal now as well. To do that, I'm just going to multiply both sides of the equation by 10. So then I've got 9,990 x's equals a very large number. But now I have no decimals. So I'm just dealing with whole values right here, which is what we want. And to finish this off, we're going to divide both sides by 99,990. Alright, so that leaves us with a 1x. Let's see what we can simplify this by. So it's very clear that we can divide both of these by 1,515.
Whoa, hold up.
Yeah, these are very common multiples of 1,515.
Of course.
So, actually I used a calculator. But in any case, it did simplify it by dividing both of these by 1515. I got 133/66.
Well, that's not so scary.
We should have just done it by 5s.
Oh,
you got one
yeah.
I'm going to do this one the traditional way, the one we've been learning, and then I'll show you guys the new way. Alright,
Oh, hi.
so on at these, right, we're going to say that x is 0.123, 1, 2, 3, 1, 2, 3. It sounds like some dance moves.
Come on, Sal. I need to
You're
Funny.
Yeah.
That's funny.
Anyways, we're gonna multiply that by 1,000, right? so that we can move the decimal place 3 times. So that gives us 123.123 and so forth. So let's go ahead and subtract these out from each other. So again, the decimals cancel out, which is very nice. We got 123 right here. And 1000 minus 1 is 999 x's. So to solve these, we're going to divide both sides by 999.
I'm a genius.
And we get 1x. But to simplify these, looks like they're both divisible by, yeah, so it looks like it's just divisible by 3. 41 3/33 is. Bam. Now that was one method. There is another way though. But this way only works as long as the decimal repeats right after the decimal value, the decimal point. So if this one was not repeating, this doesn't necessarily work unless you know how to manipulate it, okay? So this method only works if immediately after the decimal it starts to repeat. So here's what we do, is we write the number that is repeating, 1, 2, 3, and we put it over how many numbers repeated right here? 3. Well, that's how many 9s we would use. That is called the rule of 9s. And then, like we saw down here, right, we saw there. Now this is just skipping this step right here, up in here. Really? And this step, I guess. But you still need to simplify this down to 41 3/33. So we'll divide both these by 9. And we get 5/11. Alright. So let me show you guys another example because you guys, that's a really good question. Let's say this is negative 2.1 repeating, like this. Okay. Well, the answer here is to change this into a mixed number first. So we keep the negative 2, but then we change the 0.1 repeating into a fraction 1 over 9. So as a mixed number, this is negative 2 and 1/9, which we would change then into an improper fraction, negative 19/9. So on this one, let's look at the old-fashioned way. So we say x is 4.1 repeating. And we're going to multiply that by 10 so that we can move the decimal. So then it'd be 41.1 repeating. And yeah, these repeat, so there we go. Let's go ahead and subtract these out. So I got 9 x's equals, this looks like 37. And then we'll divide both sides by 9er, and we get x equals 37/9. But we could have done it the other way by making this 4, and then that's a 1 that repeats, and so we have 1/9. And then we could change this into an improper fraction. 4 times 9 is 36 plus 1, 37/9.
It all makes sense.